All right, so these are your notes on inverse functions. So a bunch of things to say about the inverse functions. That's why I left the big blank here. What inverse functions do is they undo each other. So if you did all of the steps for one function and then you did all of the steps for the inverse function, it would take you right back to where you started. So if you want to check if two functions are inverses, and we're just going to call them f and g, if you did f of g of x, you would get x. And if you do g of f of x, you should get x. All of the steps cancel out and you just end up with x. Does that logically make sense? Like as far as common sense goes, like it's all going to cancel. The steps are going to undo each other. You want to find an inverse, you are going to switch x and y. You're reversing the output and the input. Again, you want them to undo each other. So it's a total reversal. And so what that means is the domain and range are reversed. And we're going to talk a lot more about the domain and range next class. But whatever the domain of the original function is, that would be the range of the inverse and vice versa. They're just reversed. Okay. And then we are going to do some graphing here. When you graph them, the graphs reflect over the line y equals x. There's another way you can check if your answer's right. If you draw in y equals x, they'll reflect over that. Let's just real quick talk about what y equals x looks like, because we get to the graphs and everyone's like, what's y equals x? It's y equals mx plus b. You're just missing the m and the b. What is the slope really? 1, and it's plus 0. So you're going to start at the origin and have a slope of 1. It's up 1 over 1. So that's your line y equals x. That's what that looks like. So for 1 and 2, the directions are the following functions inverses, yes or no? In essence, you're a 50-50 shot, but I need to see the work, all right? What you're going to do is find f of g, that composite, find g of f. If they both come out to be x, then yes. If not, then no, okay? So f of g of x for this first one. And you do have to label because they're different. So g gets plugged into f. So we're going to have 1/3 times this whole function plus 2. And then we're going to work that out and see what we get. Don't try to force it to be anything. Just see what happens. We're going to distribute the 1/3. All right, what happens to 1/3 times 3? That's 1, so just 1x minus, all right, 1/3 times 2 is 2/3, and then we have plus 2. But I need a common denominator. This is more practice with fractions. Good, before I could even ask the question, 6/3. 6 divided by 3 equals 2. Or you could think of it like 2 times 3 is 6, however your brain wants to do that. So this will be x plus how many thirds? I'll give you a hint, it will be positive. Good, -2 plus 6 is 4, so 4/3. And then we're going to do g of f of x. So f gets plugged into g over here. You're going to have 3 times that whole function minus 2. And again, don't try to force it to be anything. Just work it out and see what happens. We're going to distribute the 3. Again, 3 times 1/3 will cancel. It'll just be 1x. Plus 3 times 2 is 6. Minus 2. And so you get x plus 4. So here's the answer to the whole thing. It's either a yes or a no. Did those both come out to just x? No. One's an x plus 4/3 and one's an x plus 4. So the answer to the whole thing is no. In fact, we knew it was no after we got here, didn't we? Because I'm going to give you points for it. Like the work is worth credit. You'll be okay. You are okay. How many steps of work is this? Or you can even just count it as 2. The first one's just setting up the problem. You're going to be all right. Promise. Oh, no points for it then. Points are for work. That's how that goes. All right, so number 2, f of g of x. G is going to get plugged into f. As a heads up for this one, this one's going to be a yes. You know, I'm going to give you an example of each thing. You have to show me what order stuff cancels in, because I get this all the time. People just slash the whole thing out and write equals x. And I have no idea if you actually understand what you did or not. So you're going to have to show the in-between steps, just as a disclaimer there. All right, 4x plus 9 gets plugged in there. So it's 4x plus 9 minus 9 over 4. Now, yeah, all that is going to cancel and just equal x, but you have to show me the order. What's going to cancel first? Good, plus 9 minus 9 cancels first. And so you have to write this step, because if all you do is slash it out, when I look at your paper, I don't know what order you slashed it out in. 9s cancel, then the 4s cancel, and you just get x. So then g of f of x, we're going to plug f into g. So this whole fraction gets plugged in over here. It'll be 4 times that whole fraction plus 9. Again, it's all going to cancel, but you have to show me what order. It's going to be the opposite order this time. What cancels first for this one? The 4s, good. Times 4 divided by 4. You get x minus 9 plus 9, which is just x. And so this one is yes. So again, they undo each other. Do you guys remember that from last year? Did you do this in algebra 2? You saw this? I know it was a year ago. All right, now we're going to find the inverse and graph both of them. Here's where I like to color code. I like to do the original graph in one color and then the inverse graph in another color. I suggest doing the graphs first. You can get the graphs without actually doing any work. Okay, see, before we even do the work, I'm going to do the graphs. I'm going to make my original function blue. This is y equals mx plus b. Make your algebra 1 teacher proud. Where are you going to start out putting a point? -2, 0, -2. And then your slope up 3 over 1. So from that point, you're going to go up 3 over 1. And just continue that for the rest of the grid. I mean, you have the space. It's not that hard. Just go ahead and put more points in because it'll make your line more accurate. So we started again at 0, -2, slope of 3. You can graph the inverse function without even finding the inverse. All you have to do is reverse those points. Okay, it's like no work. All you do is flip them around. This is the point 0, -2. So on the inverse, I'm going to have -2, 0. Just reverse the points. This is the point 1, 1. If you reverse that, you would still get 1, 1. So actually, they're going to intersect there. This is the point, what is that, 2, 4? So then you can plot 4, 2. And then you can continue it on. What's the slope of the inverse line? 1 over 3? Do you guys see that? Does that make sense? If one of them's 3 over 1, the other one's going to be 1 over 3. And then this is optional, but usually people do this to check. Dot in the line y equals x and make sure that it's a reflection. If you dot in y equals x, do you see how they're a reflection over that? Sort of kind of looks like butterfly wings. All right, so now let's go back and actually find the inverse. The way you find an inverse is switch x and y. So it would sure help a lot if there was a y in this problem. What part of this means y? Okay, so my suggestion is scribble out the f of x and put a y, and then you're just going to switch x and y. So scribble out the f of x, call it y. Everything else is going to stay put. You're just going to switch x and y. So it'll be x equals 3y minus 2. The equal sign stays where it is, the 3 stays where it is, the minus 2 stays where it is. You just switch the x and y. Then you want to get y by itself. So here's your algebra. What would you do to both sides to get y by itself? Add 2. Divide by 3. So you're going to have x plus 2 over 3. Now, if you write equals y, full credit, okay? Does anyone remember? I'll be impressed if anyone does, but I'm going to throw this question out there anyway. Does anyone remember what the notation for an inverse is? It does have f of x, but there's something else in it. Oh, good. Nice job. It's f with a little -1. It's not an exponent. It's just notation that means inverse. So you can write y, but I'll be happier if you put that because that's the more like grown-up way of saying it. All right, let's do this again. I'm going to make the original function blue. This one's cubic. So what shape is it going to be? Yeah, everyone just goes like wiggle. All right. And it's moved what direction? Down 4. All right, so we're going to start at 0, -4. And then I want to get a few more points. Let's plug in some more numbers. Let's try 1. 1 cubed. 1 minus 4, -3. So 1 -3. Let's try 2. 2 cubed. 8 minus 4 is 4. So we get 2, 4. And then let's do -1. Get a point going the other direction. -1 cubed. -1, good. Minus 4, -5. You get -1, -5. You could go to -2, but that's going to be off the grid. So that's good enough. So here's our wiggly shape. You can graph the inverse without even finding the inverse. Just reverse those points. So this is the point 2, 4. What point can I plot? Yeah, 4, 2. And then this is 1, -3. So I can do -3, 1. And then 0, -4 would be -4, 0. I'm just reversing all of them. I struggle to graph these sideways, so I have to flip the paper to do it, but I will turn it back around. Just give me a second. Actually, I still didn't do a very good job of that. But... And again, optional, but most people do this. Dot in y equals x just to see the reflection. It's just a way to kind of check your work, because if it doesn't reflect, then you could be like, oh, I messed something up. That looks cool. The reflection of that. I don't know, it looks like a vase or something. All right, so now we're going to go back and actually find the inverse. You're going to switch x and y. It would sure help a lot if there was a y in the problem. So scribble out f of x, call that y. Everything else is going to stay put. So this will be x equals y cubed minus 4. And then you're going to get y by itself. So what would you do? Here comes the algebra. Yep, add 4. And then do you remember how to get rid of a cubed? Cube root. It looks like a square root just with a little 3 out front. Cube root of x plus 4. And again, if you write y, fine, but I'll be happier if you put inverse to show that you know what that notation means. I'm not going to make you graph anymore. I thought 2 was good enough. Do you feel like you got it? Their reflection? All right, all these ones in the back, we're just going to practice this process. Just find the inverse. That's all it is. So scribble out f of x. We're going to call it y. These do get like heavy with the algebra sometimes, but as long as your algebra skills are intact, you're going to be okay. All right, switch x and y. We'll have x equals 2 over y minus 1. You want to get y by itself. The problem is y is in the denominator. Give that a hug. Here's what's going to happen. We're going to multiply this entire thing to the other side. Are you following me? I know, wake up. There's only a few more problems. You guys are going to be okay. You have to know how to do this, so care now. We multiplied that to the other side. Algebra is just moving things. It's like, I think I'm going to move this over here and move that over. All right, now we're going to divide over the x. So divide both sides by x. You'll have y minus 1 equals 2 over x. And then what would be your last step? Plus 1. Again, you can write y. I'll be happier if you put inverse. It'll be 2 over x plus 1. This is what your homework is like, is just finding inverses. All right, what will be the first step for this one? What's it going to look like when you reverse them? X equals, good. Y plus 2 cubed, good, over 5. Everything else stays where it is. And then you're undoing all those steps. It's order of operations in reverse. So what are we going to move over first? Trying to get y by itself. Yep, multiply 5 times 5. So 5x equals y plus 2 cubed. Again, we're just trying to undo all those steps. So then what? Cube root. And then subtract 2. Now you can write this minus 2. But you remember we talked about this? Like if you have cube root of 5x minus 2, do you see like a potential issue? Like it could look like it's underneath. So you should put it out front. Again, I don't really care. It's just, we normally put those in front of the root so it doesn't look like it's underneath. So when you subtract the 2, when we did completing the square, you all did that just fine. So same thing. All right, here, switching x and y. It will be x equals 1/3, a 5th root, y plus 8. All right, then what? Multiply by 3, good, to get rid of the 1/3. So 3x equals 5th root, y plus 8. How do you get rid of a 5th root? Put it to the 5th power, all right? It'll be 3x to the 5th equals y plus 8. And then subtract 8. I actually kind of like doing these. You're just undoing all of the steps that were there. All right, again, switch x and y. This will be x equals a 7th root. And then underneath of that, 2 times y minus 9 over 6. You just have to get all the steps in the right order. So what's the first thing? Times 6, right? So it'll be 6x equals all the rest of that. I'm not going to repeat it all. Then what? Yep, to the 7th power. And then divide by 2. And then last, add 9. Like these appeal to my math brain. Like just undoing all the steps that are. Well, they're not hard. Oh my gosh, give me a break. You write way more than this in English and history class, correct? Take it on. Oh, well. Okay, well, you guys are going to be okay. One more. Switch x and y. It'll be x equals 9 over 3 y plus 4. All right, so all of this, everything in the denominator is going to get multiplied to the other side. You're going to multiply all of this to the other side. So it will be 3y plus 4 times x equals 9. Again, you're just moving stuff. We moved all of this over here. All right, then what? Divide by 3. All right, 9 divided by 3, we 3. Divide by x. You get 3 over x, and then subtract 4.